in the last lesson, I gave you some homework, and I thought I'm going to do it in front of you quickly. I'm not going to, this is homework, so I'm not doing it in the way that I would do it in class. But I just like this little checklist. And the checklist says, look, what am I doing? I rewrite all the composite numbers as products of their prime factors, use the exponential laws to raise all the powers, use the rule for division to move all bases into the numerator, and then simplify. So let's see how I would do that. For the homework question, the 6 needs to be broken down. The 2 needs to be broken down. So let's even do that. 3 times 2, 2 squared, and then this is already a prime 1. So that's fine. But I need to make sure that I don't forget about these things. Then the next step would be to say, look, I'm going to apply the laws like that. Let's just make sure. Yep, because there's a 1 here and a 1 there, so it's being applied. And then on the bottom, I'm going to get 3 to the 2m. Now, the good news is 2 to the 2m times 2 to the minus 2m. Those added together, and they knock each other out. And then this over this, and the final answer is 1. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. It was just me doing the homework from the previous lesson. If you weren't in the previous lesson, then you would find that a bit odd. So let me know if you followed that in the chat. So thumbs up or a acknowledgement, or if you were like, even an unhappy face if you didn't like it, a happy face if you did. And then for the next one, the 3 is already like that, but the 27 can be broken down. And the 9 can also be broken down. And then I'm going to leave this like this. This is going to become 3 cubed. This is going to become 3 squared. And then what I need to watch out for is that that 3 is multiplied by both of those. So I've got 3 to the x plus 1, and I've got 3x minus 6. And then on the bottom, I've actually got 3 to the 4 x minus 2. And then if I put the top together, I get 4x minus 5. And on the bottom here, I get 4x minus 8. There's different ways of doing this, but some students like to split them apart. Some people like to take it to the top straight away. All good. You basically are going to cancel that out. So you get 1. And then if you bring this to the top, it becomes a positive 8. And that's a negative 5. And when you add those together, you get 3 to the 3, which is 27. And so the homework is concluded. Give me a happy face if good. Give me a meh in the middle face if you're in the middle. Give me an unhappy face if you were like, that went by rather fast. And then we can go from there. All right. So if we move on to the main topic for today, we are dealing with rational exponents. And rational exponents is basically exponents where there's a fraction. And so there's a couple of definitions I want to talk about to get going. The first one is, what does it even mean when you have a power that is a fraction? And how do you deal with it? Now, the one way to deal with it is actually just to say, look, it's just like any other number. The laws apply. So if you think of 32, 32 can be broken down into 2 to the 5. And then what I can do is I can say, look, I can just say 2 to the 5 times 3 over 5. I can imagine that being over 1, and I get 2 to the 3, which is 8. So that wasn't very hard, right? That was just using it like you normally would. And so we call these ones with fractions rational exponents. But then there's some kind of weird theory, not weird theory going on, but we say the nth root of a is a to the power of 1 over n. So what does that mean? Well, it means like if you had the square root of 16, that is the same as 16 to the power of a half. Now, to show you that this really works, the square root of 16 is 4, because 4 times 4 is 16. But you can also say 4 to the power of 2 is 16. And what is 2 times a half? Well, those are going to cancel, and I get 4 to the 1. So we see that in this case, that law does hold. Another way of seeing this would be like if you had the cube root of 8, it's the same as 8 to the power of 1 over 3. It'd be a similar statement. So thumbs up if you got that, thumbs down if you haven't seen that law before. So Siamtanda, Caitlin, Stephen, Amachle, what do you think there? Fantastic. Okay, now the other law that we need to bear in mind as we go forward today is when we have a fraction where the numerator is not 1. So what does it mean when the numerator is not 1? So it's more this situation down here. So let's say if I have 8 to the power of 2/3. Now, what this law says is that actually this thing at the bottom could be written outside. So we could have 8 to the power of 2 cube root, and that would be the same thing. Okay, so let's actually just check this. So 8 to the power of 2/3 is the same as 8 squared to the cube root of 8 squared. So basically the thing at the bottom can also go outside. So 8 is 2 to the power of 3, and then the 2/3 is just hanging outside. And what does that give us? Well, that is just 3 times 2/3. So then I get 2 to the 2, which is 4. So we know that this thing over here is 4. Now, if this is true, this part over here also has to be 4. So let's see. If I square 8 squared, I get 64. So that's just that. What is the cube root of 64? What is the cube root of 64? Oh, Stephen, I see some surprised faces there. That's good. It means we're learning. What is the cube root of 64? So the cube root of 64 is actually just 4. Because if you go 4 times 4 times 4, you get 64. And this makes my heart very happy because it's true that they both equal 4. Okay, so that is why that law over here, it really is true. And so today, we're going to practice kind of getting to know that law a bit better, both these laws. And what they're doing is they're connecting things to the power and like radical or root signs. Okay, so that's kind of the intro for today. If you need more of an intro, please do ask questions as we go, but let's practice some questions together. So let's go to, I want you to try and do for me questions 1 to 4. So 1 to 4 on the board, and using those laws that I just showed you for rational exponents, I'll even write them down here. A to the power of 1 over n is the nth root of a, was the one statement. And the other statement said n, then that was a to the n. And see if that can help you And then while you're doing these, just say 1 done when you're done with 1, 2 done when you're done with 2, and so on. Okay, cool. Okay, let's have a look. What's the answer going to be for number 1? I think I agree with you, Simtanda, because that's 3 over 1, and it's going to cancel, and so the answer is 2. Yep. So we've done that one. Let's do number 2, 3, and 4. Yeah, Simtanda, what is your question? How can I help?
Sir, so basically number 1, I did it in a different way. So basically I multiplied the 8 with the 1 over 3. Then I changed it into using this law. A to the power 1 over n is equals to n square root of a. So I changed it into 3 square root cube root 8. Then it became
Perfect.
2.
Perfect. So that is an equivalent method, completely 100% full marks. Yeah. So all good. It's like one of those things where we just have a choice in maths, but you are as 100% as the next person. Thanks
Okay,
for the
thank you, sir.
question. Let's see how we do number 2, 3, and 4 here. I think that would be my first step. All right. So I think that I would bring that to the top, and now I'd multiply that by that, and I would get 2 to the 4, and my answer was 16. So number 2, answer is 16. Let's see answers for 3 and 4. So just say 3 done, 4 done when you're done. So it seems to me like we get 2a squared b to the 4 for number 3. Nice. And then for number 4, I definitely am using all my colors today. I'm going to change this from what's called surd form or radical form into exponent form because it's just easier to deal with. And then I'm going to break 32 into its powers. And I feel like 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this must be 2 to the 5. And then 5 times 2 over 5, there's always a 1 there, and that cancels. So I get 2 squared, which is 4. Okay, so you can see how you need to be comfortable changing between the different laws. Are there any questions about what I was doing? Are there any questions about what I was doing or how I was doing it? Okay, so if there are no questions, I'll move on, but I just want to give a moment because that's the wonderful thing about being live. You have an opportunity to put your hand up, have a chat, and clarify. And especially while the classes are still small, take advantage of the opportunity. Yes, Stephen, how can I help?
Oh, sorry, I wanted to ask you, is it fine if we made the step shorter?
Yes.
If basically what I'm trying to say, if I just took the sum, I put it in the calculator and I got the answer. Does
Ooh.
that lower my marks or something?
Okay, so in this is a great question, Stephen. So you'll notice, and I didn't spend too much time focusing on this just because I wanted to zoom in, but it says simplify the following expressions without a calculator and leave your answers, let's have a look, with positive exponents. And this is a pretty traditional way to describe these questions. So if you just went straight to the answer here, you would get no marks. So it's more we want to see that you're comfortable using the laws of exponents and surds. And so you have to show us evidence of that. So that's a really important question Stephen has asked. I hope you all heard that loud and clear. In this topic, you can check your work because, I mean, how am I going to know as a teacher whether or not you did it? But you have to show the evidence of your thinking to get full marks. Okay, then let us go on to a next question. Let us do some multiple choice. Let's do some quick fire multiple choice questions. So there's the multiple choice question. What is the answer going to be? A, B, C, or D? Oh, flipped. What did I do? I think I pressed the button by mistake. Sorry. There's a couple of ways you could do this. Some of you might write 16 as 4 to the 2, and some of you might write it as 2 to the 4. And you're both correct. There's nothing wrong with that. And all you need to do here is 2 times 3 over 2 gives you 4 to the 3, which is 64. Or if you multiply these two together, you get 12 over 2. So that's 2 to the 6, which is also 64. And so the correct answer is 64. Perfect. Very nicely done. Everybody is Caitlin, well done. So let's do another one. Can you answer, what's the answer to that one? The answer to that one. What is this going to be? positive 2 over 1. That's just going to be 1. So the answer must be 4. Yeah, so the answer is B. It's 4. It's going to be 4. Okay, let's do one more of these. We're getting close to our break time. Let's do any questions before I move on? I think I saw B's in the chat. I don't know if there were B's from the previous one or this one, but just shout if you have a question. I'm going to assume you can put your hand up. I want to give you a slightly harder one here. What is that going to be equal to? No calculators, just using logic or using your knowledge of exponents. What is my first step going to be in this question? You can just pop your hand up and tell me audibly if it's quicker, or put it in the chat. What's the first step? So CM Tanda has suggested D is looking promising. I'm not sure because I haven't done it, but I was thinking, how do I make 8 over 27 easier? And I think I'm going to write it as that. Don't know if you agree with me. Let me know in the chat. But I think that looks pretty good. And the reason I like it is now I can take this thing and apply it here and apply it there using law 3. And so I get 3 times minus 2 over 3 for that one. And then I get for that one. Now what that gives me, I still have to keep working, but that's where I'm going with this. I always like to write this over 1, so it helps me see that those can cancel. So lock your answers in now so I can see. I want to see you commit. You can't stay on the fence. Okay, Stephen has committed, and CM Tanda and Sia are in the same corner. Amakle and Caitlin, what are you going to do? Where do you think it goes? Caitlin agrees. Okay. And so does Amakle. Okay, and I think you guys are all completely right, because if you move these up and down, what you see is you get 9 over 4, which is D. Perfect. Okay, let's do, I think, one more, then it's time for a bit of a break. Some exercise breaks, I think. Can you tell me what, actually maybe 2 more, because these are quick, relatively simple. This is an exponential equation. What is n going to be here? What is n going to be here? A, B, C, or D? Think about your knowledge of exponents. Okay, Simtanda has locked in an answer. Anybody else? Stephen agrees. I was just thinking that 8 has got to go. Hey, like that is the problem. And so if I use law 3, I get 2 to the 24 because I multiply that. And then because the bases are the same, it must be B. And Caitlin agrees. Okay, I know that one. Let's do one more, because the thing about the standard class is I do like to push you a bit further. So we go a bit quicker than the F class, and we also do more questions. So let's see if we can do this one. What is the value of n for this one? What is the value of n for this one? And welcome to Sange, who's just joined us. What is the value of n? So there's a lot going on over here. The question is, how do we make it simpler? So we've got that bit, and then we've got that bit, and then that. Now, I think this, using law 2, if I bring, you can say 8 minus 10, if you know that, or if you, sometimes what I do is I just do it like that. I bring it to the top. It's the same thing though. And then I've got x to the minus 2 to the halves equals x to the n. So lock your answers in while they're still. And then this is going to become x to the minus 1, because minus 2 over 2 cancels, yes. Oh, goodness gracious. What's this going to end up being then? Okay, what's n going to be? N has to be minus 1, of course, because the bases are the same. And so the correct answer would be A. Okay, everyone, that was a great first half of the lesson. I think what I want to do now is I want us all to take a brain break. Let me get rid of this first. I want to move this down if I can. There we can. So before we even think about any puzzles, I want us to turn our cameras on, and I want us to stand up away from our desks. I don't want any sitting. If you were in my class, I'd make you do this too. If we had a double, we would definitely be doing this. So pop your cameras on so I can see your lovely faces if you can. And what I want you to do is to start with a little stretch. So a nice shoulder stretch. Oh, I can feel my shoulders are tight. Stretch, and then let's roll your shoulders. And roll them back. And then roll them forward. And then let's shake out our arms a bit so get some blood flow. Shake out your legs so that some blood flow to your legs. And then maybe let's do some slow rotating. So just a little bit. And then as your hips loosen, you'll feel like you can go further. Oh, I can feel how my body is appreciating this. Okay, and then the last thing for exercise for today is to do some jumping jacks. The intention behind jumping jacks is to get your heart rate up. That way you forget about maths. Your brain is like, I'm done with maths for today, and it resets your attention. So make sure the space around you is clear. Jumping jack just looks like this, and we are going to do 15. So 3, 2, 1, let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and whew, my body feels like it has had a bit of a reset. So tell me how you are feeling in the chat. And here is today's logic puzzle. Can you solve it for me? And let me know your happy face, unhappy face. Did the exercise help? See, Mtanda, that's exactly what we need. A little bit of a heart rate spike. And then you just feel the endorphins just kind of float around a little bit. So that was the goal. Okay. Anybody else? Machle, Stephen, how are you feeling? Did you do the exercise, Caitlin? How are you feeling now? I know it feels a bit strange at first, but I can tell you, once you get this, you'll be like asking your teachers at school to do it too, because There's something about our brains. I don't know. It really does help. Exhausted. Yeah, jumping jacks are no joke. No joke. Okay, tell me what a fancy biscuit plus 2 bananas times a chocolate biscuit is. Tell me what that is. Oh, and my camera is a bit out of focus there. So the chocolate chip cookie is definitely 10. So that is no doubt. And then banana is 2. It is, but there's 2 bananas. So I want to suggest to him, Tanda, that each of the bananas is 1. Because 1 banana, 2 bananas, 3 bananas, 4. So what is the extra special biscuit going to be then? What is the extra special biscuit going to be? So Stephen has suggested 3. Stephen, I agree with you, because that's the only way we get 8. And now we just need to make sure we understand what BODMAS says. So what is the final answer going to be? What is the final answer going to be? So BODMAS says you have to do this first. So there's a 10 and then a 3 plus a 1. And so Siamtanda, you are absolutely correct. It is 14. Okay, that is our break and puzzle section for today. I hope that your brain feels relaxed, like it's had a bit of a walk around the park. And we're going to go back to learning our sort of formal mathematics now. So this doesn't look too hard to me, but let's try and do a couple. So let's look at what is 100 to the power of minus 3 over 2. Let's do that one. Can you tell me what that is going to be equal to? What is that going to be equal to? Your answer in the chat there. As always, the number breaking down into prime bases seems an important idea. And so I'm going to do that to start with. But what is my final answer going to be then? Ooh, that looks interesting, CM Time. I haven't worked it out, so I'm curious. I know that these two are multiplied, so I get 10 to the minus 3. But if I want to make this a positive power, remember I've got a 1 on the bottom. So then I think I need to bring this below the line. And what is that going to give me? I think that is 1 over 1,000. And so we get 1 over 1,000 for that one. Let's do this one as well. Let's do E. I just want to test you guys and make sure that you're comfortable with this type of question before I move on. So do the one in the red circle as well. What do you get for the answer for that? What do you get for that? So 81 is reminding me of 3s and 9s. I guess I'm going to go with 3 to the power of 4. And if you want on your calculator, there is a fact button. So if you go 81 fact, it should show you what this is. And what is my final answer going to be for this one? Okay, so isn't it 243? Oh, I think you might be onto it, Caitlin. Let's have a look. So 4 over 1, that cancels. So I've got 3 to the power of 5, which is 3 times 3 times 3 times 3 times 3. And that's 9, 27, 81, 243. Yes, you are correct. It is 243. Okay, so these all kind of follow the standard templates, and I don't think we need to do more. I will put extra practice material on Google Classroom so that you can practice this more, but I think you guys are good with that type of question. Let's look for a different type of question like this one. So again, you're not allowed to use your calculator, and you just need to use your knowledge of exponents. Let's do number 5. Can you simplify that for me? Where would you even start? With that big radical sign, that cube root sign, how would you deal with that? Any ideas? Well, how do we deal? Earlier in the lesson, we spoke about a rule that maybe can help us. So I think the cube root is the same as raising something to the power of a third. And then I was thinking 27 could be written as 3 cubed, and 64 could be written as 4 cubed. Now, what I want to know from you guys is, what is the final answer going to be? What is the final answer going to be? And how do we deal with that floating red third? I think that third needs to be applied to all of these. And 3 times a third is just going to be 1. 3 times a third is going to be 1. 6 times a third is going to be 2. And then a third times 3 is going to be 1. So that's 4 to the 1. And then c to the 9. So the 9 times a third is going to be 3. And so your final answer should be that. Give me a thumbs up in the chat if that makes sense to you. Give me a thumbs down or unhappy face, happy face. Yeah, Siamtanda, let's go to you. What is your question?
Sir, if we went straight to the answer, from here.
Yes.
Let's say we applied the cube root to 27 and we
Yeah.
applied to 64 and the
You would get full
it's
marks
five.
if you understood that the cube root of 27 is 3. The cube root of a cubed is a. The cube root of b to the 6 is b squared.
Square.
Yeah, the cube root of 64 is 4. The cube root of c to the 9 is c to the 3. So you could do that, yes. In this question, you could. I just wanted to show you the connection, but you're right. In this case, if you understand that, you're fine. And thank you for sharing that point of view, because now everyone kind of gets there's two ways, and probably this is quicker. Yeah.
Right. Thank you, sir.
Okay. Now, last bit for today. Now, again, I am pushing you guys because I want to know, can you, oh wait, I've given that already. Let's do this one, yeah. Can you simplify the following expression? Can you simplify the following expression? Go for it. Now you've got fractions and negatives and all sorts. See if you can solve that. Where would I start here? I need to be careful because there's lots of landmines here. I think I would probably apply this to here, but remember, this needs to be applied to that, and it needs to be applied to that. Whereas here, because that's in a bracket, that can stay separate. So it's a bit of a minefield, but you would have that as the step on the top here. And then here, you would have that. So I'm going to give you that guidance, because a very common mistake here would be to only apply the minus 2/3 to like this and leave out this. But there's no bracket around this, so both of these need to get some action here. Whereas here, it's in a bracket, so this essentially distributes eventually into that. I don't know if there's a question about that, but please do raise your hand if you're unsure there. And so here I would have six. Two, so I get, this is really just a 2. So I get 3 squared, or x squared, and then that's really just x squared. And that is going to be 3 cubed power of that. That's going to cancel. And then we're going to have 3 squared there, and then that 3 is going to cancel. So I get 3 to the minus 2. And then if I bring it to the top, I'm going to get 3 to the 4, which is 81. thumbs up, thumbs down. If you thumbs up, thumbs down for how that felt. Or unhappy face, happy face, meh face, whatever, wherever you are in the process of learning. So, Stephen, what I'm going to suggest is have a look at the recording, because I did go quite quickly there. And the big problem here was really, how do I deal with this bit here? And what I did was I said, look, it's easy to apply this because there's a bracket here, but this part has to be applied to that and to that. And understanding why that is really the difficult part. And I think if you rewatch it, it will become a bit easier. If we see how they did it here, here's a model answer. Now, did they do it a bit differently? Let's have a look and see. Maybe you prefer this way. I don't know. They broke the 27 down first, and then they distributed this in here like that. And then they canceled that. Actually, that's not bad either. Hey? Like you could cancel that. Then I would have moved probably this to the top. So you get 3 to the minus 6. And then this would have been canceled. I don't know why they should have just canceled this out a long time ago. And then probably doing it, oh wait, it's 3 to the minus 6. And then you have a minus 2/3 outside, which gives you 3 to the 12 over 3, which is 3 to the 4, which is 81. So I like some of what they did here. I just feel like they made it a bit more difficult than it needs to be. But I like the parts like this. But yeah. Cool. Okay, now we've got a little bit of time, yes, left. Okay. That's actually, tell me what the answer is in the chat. So just so I know, kind of that you know, what is X going to be? What does X have to be here? This is kind of previewing the next lesson. It has to be 3, right? Because you know this is 2 to the 3. So this is a very simple exponential equation. And in the next lesson, we're going to be looking at exponential equations. What if I said to you, solve that? Is that a bit trickier? What would you do with that exponential equation? In fact, I want someone to tell me their thinking, because this is harder, but it's not impossible. What do you think we should do? Okay, Siamtanda, tell me how you would approach solving this. It isn't as simple as the last one, definitely.
So basically, I'll take 125 to the other side and make it a positive.
Okay, so first thing is take away the headache of the negative. And you know that if you move it to the other side, you're good. I would do that 100%. What would your next step be?
Then I change 125 into a product of its prime factor. So it
Yes.
will be 5 to the power 3 in brackets, then to the power 2x minus 3.
Okay, I love it. And you can see how that feeds off what we did earlier in the lesson, right? Make your prime, make your big numbers into prime bases. Okay, what's next?
So basically, I multiply out the exponent. So it's going to be 5 to the power of 6x minus 9.
Okay, well done. The thing that students will get wrong is they won't remember that the 3 needs to be applied to the minus 3. Okay, now we're in business. I want everyone else to have a go at this. So you really helped us there to crack this open. It was step 1, move it across. Step 2, break into prime factors. Now I want you to solve for X.
Solve it now.
Yeah, go for it.
So basically, we equate the exponents since the bases are the same. So it's going to be 2x plus 1 equals to 6x minus 9.
Perfect.
We put the x's in one side and we put the consonants in on the other side.
Okay.
Basically gonna be what you call 6x minus 2.
Yeah. And then the 9 becomes positive, so we get 10 equals 4x. And then what's the final answer going to be?
X is equals to 10 over 4.
Yeah. Or we could say 2.5. Perfect.
2.5.
Okay, so that's an example of a slightly harder exponential, but still not that bad. Then let's do last one for today. What is the answer to that exponential equation? What is the answer to that one? Amakle, what do you think? This is a bit like the bases aren't the same. How can that be? What is the only way that 2 to the power of something can be 5 to the power of something? If you go back to the previous lesson, there was a definition that might be helpful here. So CM Tanda has been very generous with offering opinions. So Stephen, what do you think, ladies? Caitlin, Amakle, what do you think for this last one? You don't have to be right. I just want you to commit to something here. Or describe why it's difficult. Why is it difficult? Because you can't really compare the bases in the same way. I don't want to steal your glory. Who's going to claim it? Okay. Okay. No problem, Stephen. Not at all. That's why we're here. CM Tanda, what do you think? What do you think? Do you have some insight, maybe?
I don't know if it's right, sir.
Yeah.
I'll try. So basically, you divide both sides by 2x.
Okay. Okay. So here's the big thing. If I said to you, what is 2 to the naught? Could you tell me?
Is 1.
Okay. Could you tell me what is 5 to the naught?
1.
Okay, so what do you think x is going to be in this to solve this? What's the only way these two can be true? So Stephen, I think Stephen has seen it here. If I made that 0 and that 0, would this statement be true? It would, because 1 would be equal to 1. And so the answer to this one is x is 0. I know, it was a sneaky one at the end of the day to throw at you, but I think that is the end of today. So yeah, we've learned a lot today. Like I would definitely have a look through the recording because we did a lot.